Hello guys. So in this lecture, this is the first lecture of the section uh, standard template library. Okay, uh, in which we talk about the standard template library. So in this lecture, we'll get to know what is a standard template library. So STL is nothing, but it consists of containers. Okay, and it consists of algorithms. Okay, there is a library in which there are, by including that library we can use certain functions that can help us simplify the process. Okay, like we can work with some containers by using the algorithmic library. Okay, this gives us uh, uh, a number of functions to work. Okay, number of functions which make which simplify the task. Okay, now we will talk about algorithms in the later chapters. In this lecture we are going to talk about containers. Okay, so what are containers? So containers can be further divided into four types. Okay, first one is sequence. The second type of containers are adapters. Okay, the third type of containers are uh, associative. Okay, associative. And the fourth type of containers are unordered. Okay, unordered. Now we'll talk about each one of them. Okay, so let's talk about the first container. Okay, so yeah, so sequence container we'll talk about. Okay, sequence containers. Okay, so when we talk about sequence containers, sequence container includes, the first one is a static array. Okay, so okay, I got it wrong. So the first one is static array or simply array. Okay, the array that we create in our program, any kind of array like integer array this way. Okay, int arr, and we give it a size, right? 3 equals to, let's say, 1 2 3. Similarly we create an array of string, right? Similarly we create an array of string by giving it a data type string. Let's say arr, we name it again. Okay, 3. It is going to store, let's say, okay, let's say it is going to store the name of the countries. Okay, USA, then let's say Russia. Okay, and let's say the last is okay, so the last, let's say, is India. Okay, India. So yeah, this is how we store strings. This is how we create a static array of strings. So what is this static array? Okay, this is the first sequence container. So what is this static array? Static means something which do not change. Okay, so static array is an array whose size cannot be changed. Okay, size remains constant. Okay, remains constant. Okay, so once we declared a size to the array, so it remains constant. Okay, either we write it this way or we write it this way. Okay, we want to create an array. Okay, array of type int, and let's say the size of the array that we want to give is 3. Okay, yeah, so arr is the name. Okay, equals to 1 2 3. This array can also be written this way. Okay, yeah. So now the functions that we can use within the static array are, first one is the size function. How do we use this function? So let's say we want to find the size of this array. Okay, let's say we do not declare it this way. Let's say we write it this way. Okay, array int, okay, arr, okay, equals to, let's say, 1 2 3. Here we know the size. Okay, so int n, because the size will be an integer, so we create an integer variable to store it, is equals to arr. We have to find the size of this array, right? Dot size. Okay, we use dot operator here. Okay, so this is how we'll get the size of the array. Okay, let's suppose here we already knew how much element it has. Okay, we could have simply assigned n is equals to, let's say, 3. Okay, but in case we do not know, so what are the cases when we do not know the value? So let's suppose we have only, we declare an array of type integer. Okay, arr. Okay, now let's say we declare a integer variable n. Now we take input inside this integer variable. Okay, we do not know, right? It can be anything as per the um, value given or provided by the user. Okay, now we want to find the, now what we do is, okay, so let's say we use for loop here. Okay, okay, and we insert the values, okay, inside the array. Okay, arr of I. Okay, like this. Now if we want the size of the array, we already know it's going to be n. Okay, but let's say we want to find it, so we can find the size uh, by simply creating an integer variable int n and giving it the value arr.size. Okay, this way. So we can use size function. We can use front function. Okay, front function, how do we use it? We write arr dot front. Okay, what it gives, okay, this gives the element which is at the front of the array. Okay, let's suppose the array is 1 2 3, then arr dot front will give the one element 1. Okay, so if we try to print it, it will print 1 in the output. Okay, there is a function called back. Okay, back. So what this function does is that if we try to print arr dot back, okay, it is going to print the last element, which is 3. Okay, so it will give 3 as the output. Okay, now there is one more function. So the last function that we talk about is at I. Okay, at I gives the element at index I. Okay, so let's suppose we have an array arr equals to 1 2 3 9. Okay, now we want to know which element is present at the index 3. Okay, so this is the indexing. Okay, we already know that 3 exists. Okay, but now in order to print it, what we can do, arr dot at I, we can use add function to know what element is present at the index I. Okay, so in place of I we can give 3 and we'll get the output 9. Okay, so let's check this. Okay, let's get back to the Visual Studio Code. Let's create, okay, so arrays. Okay, dot cpp. Okay, okay, we have already created this array dot cpp. Okay, now let's try to write the boilerplate code. Okay, I use stream. Okay, using namespace std. Okay, okay, so we have written the boilerplate code on already. Now what we'll do, let's say we create static array. Okay, array of type int. Okay, arr. Okay, let's say we take a value, what is wrong with this? So okay, so we'll have to include the library as well. Okay, has include array. Okay, I think it should work now. Okay, we have to give the size as well, I think. Yeah, so now it works. Okay, in case of static array we cannot okay, so I was doing a mistake. Okay, so let's correct the mistake. Let's go back. Okay, so here we cannot write it this way. Okay, this is wrong. Okay, so we'll have to give a size to the array, otherwise it is going to give us error. Okay, so we cannot do this way. So this is why it is called static array, because we have to give the size. Okay, size is constant, size cannot be changed. Okay, there are later. So yeah, this is why it is called static array. So we have given the size already. Now if you want to store the size, we can also use size array. Okay, so arr dot size will help us to get the size of the array. Now if we try to print size, arr dot size, sorry, we have stored the size inside the size array, size variable, right? So let's try to print it. So at the start the size will be 4 because we have already assigned it the size. Okay, the size is not going to be 0. Okay, so this is the example of a static array. So let's suppose, let's say we give it we give values inside it. Okay, so let's suppose we don't take it in the input. Okay, so let's say 1 4 7 and 11 are the 4 elements. Okay, now let's say we want to print element at index 3. Okay, so what we'll do, cout arr dot at will give the index, so index 3. Okay, let's see what it prints. Okay, so it will print 11. Yeah, so 11 is the output. Now add function, we got to know how to use add function. Now to test whether the array is empty or not, we'll use empty function. Okay, cout arr dot empty. I haven't told you about this. Okay, we can use this function as well. Okay, now this will give the boolean. If the array is going to be empty, it will give 1, otherwise it is going to be 0. Yeah, so it gives 0. Okay, let's erase this, let's comment this. Okay, Now see, so it is giving 0 because array is not empty. Okay, array has 4 elements. Now let's comment this out. Okay, now to access the first element, what we can use, uh, dot front function. Okay, see out arr dot front. This will give us the first element of the array. Okay, let's see. Yeah, so it gives 1. Okay, let's change the front element, let's change it to 101. Let's see, it gives 101. Now let's access the back element. Okay, so we'll write simply back. Okay, that will give us back element. Yeah, so 11 is the last element, so it gives the last element 11. Okay, now yeah, this was all about the static arrays. Now we talk about vectors. Okay, what are vectors? Okay, so let me take you to the next page. Okay, let's add a new page. Now let's talk about vectors. Okay, so vectors are dynamic arrays. Okay, let's talk about vectors. So vectors are nothing but dynamic arrays. Dynamic arrays. Okay, what I mean by dynamic arrays is that the size of the vectors can be changed. Size of vectors, okay, can be changed. Can be changed. Okay, so let's suppose initially the vector was having size 2. When we try to fill elements into this vector, what happens is that so initially it would have the size 0. Okay, so if we try to add element, okay, upon adding one element, let's say its size becomes 1. Okay, now upon adding the next element, since it is already filled, the size doubles each time. Okay, so the size becomes 2 now. Okay, and the second element also gets added. Okay, now upon adding the third element, the size of vector is 2 right now. Okay, so if we try to add third element, so the size becomes the double of the initial size. So initial size was 2, now the size becomes 4, and the third elements get inserted. Okay, so let's suppose first element was 1 and second element was 22, third element was 0. Now if we try to fill the fourth element, the size won't increase and it would simply get added. Okay, so let's suppose the fourth element was 7. Okay, now if we try to fill the vector with one more element, since the vector is already full, so the vector expands its size and it becomes the double. Okay, now the vector has 8 blocks. Okay, yeah, so now the vector has 8 blocks and the fifth element gets added. Okay, let's say it is -5. Okay, yeah, so this is how the array looks like now. Okay, 122. Let's erase these values. Okay, okay, so the vector becomes, let's say we add -5. Yeah, so this is what the vector looks like. And there is indexing in case of vector. Okay, so if you want to access any particular element on the basis of their indexes, we can do that simply. Okay, now let's get back to the Visual Studio Code and let's see how the vector works. Okay, so let's work with the vector now. Okay, vector so what is the syntax of initialization of vector? Okay, so we'll write simply vector. First we will include the library of vector, so has include vector at the top. Okay, has include vector we have to write at the top. Okay, now how do we, what is the syntax? So syntax is this. Okay, so vector, what data type the vector should have? It should have, either it should have string or either it should have integer as the data type. So you can create integer, string, character, or boolean vector. Okay, I'm not creating boolean vector right now. Okay, so you can create these many vectors. I'm creating integer vector right now, integer arr. Okay, let's say now in this case, let's say we store 4 elements inside it. Okay, now we do not know the size. Okay, so to get the size, we can again use the size function. Int size equals to arr. You can name, this is the name of the vector. Okay, you can name it anything. I'm naming it arr right now. So arr dot size will give us the size of the vector. There is an empty function as well, empty function, which is going to give the boolean whether the vector is having the size 0, sorry, whether the vector is having any elements or not. So if the vector won't have any element, it will give us 1, otherwise it will give us 0. Okay, there is okay, we can sorry. Okay, now we can use two To push the element into the vector, we use pushback function, and inside this we give the element. Okay, okay, the element that we want to push into the vector. Okay, and pop back, these are the two functions that are used to eliminate. Pop back is used to remove the element from the last of the vector. Okay, remove element, remove element from end, from end, okay, of vector, of vector. And pop back, push back, here the element. Okay, so let's suppose we write push underscore back. Okay, 5, it is going to push the element 5 at the end of the vector. Let's suppose the vector is v, so v dot push back we write. Okay, same case, same way in the pop back. Okay, v dot pop underscore back will remove the last element. Okay, let's see the example. Okay, so let's look at the example. So let's suppose we have a vector int arr, okay, is equals to, let's say we have 1 3 5 7. Okay, now if you want to add one more element at the end of the vector, okay, what we'll do, the name of the vector is arr dot push underscore back, and the element that we want to push, let's say I want to push -5 at the end, so -5. So now the vector looks something like this: 1 3 5 7 and -5. Okay, now the vector becomes this. Okay, so now how do we use, let's say I want to remove this last element now. Okay, so to remove this last element, I'll write arr, the name of the vector, then dot operator, then pop underscore back. Okay, and we don't pass element here. Okay, because we have to only pop the element. So now after this, okay, the array looks something like this: 1 3 5 7. Okay, and the last element, this element gets removed. Okay, so yeah, let's get back to the Visual Studio Code and let's see how it works. Okay, yeah, so let's create the vector int. Okay, let's say v, I name it. Okay, and let's say I give it 4 elements: 1 2 3 and 4. Okay, yeah, so what is wrong, I haven't included vector, you know, library. Okay, so as include vector. Okay, now the vector should work. Yeah, now it is working. So yeah, now I want to push an element 5 at the end. Okay, so I'll write v dot push back 5. Okay, now let's see the new vector. Okay, to print the whole vector, what we can use, auto keyword. Okay, auto x belongs to v. Okay, for auto x belongs to v, see out x, let's say we don't push, we don't, you know, end the line, we simply put the space. Okay, now in case you are confused, what is this auto keyword now? Okay, so auto is used to identify, auto identifies the data type itself. You don't have to give it a data type. You can give the data type, like in this case I knew the data type already, that it is int. Okay, but in some cases you do not know what is the data type, so in that case you can pass auto. Okay, in the case of int also you can pass auto because it simplifies the process. So for auto x, okay, you can write, you can give the name anything. Okay, this is the name of the variable. For auto x belongs to v, this denotes the element. Okay, and assume that each time it goes to the next element until it reaches the end of the array. Okay, each time this x represents the element, next element. Okay, so let's suppose we write cout x and then we give this. Okay, so after x the space also gets printed. Okay, now let's see, let's suppose the array was 1 2 3 4. Okay, so initially x represents this value 1. Okay, so 1 gets printed, and then due to this, okay, empty string and there is a space in between, so a space also gets printed. Okay, there is a space. Okay, then x, next time the x represents 2. Okay, next time the x represents 2 and 2 gets printed, 2 gets printed, and then again space gets printed. Okay, then next time x represents 3, so 3 gets printed, and then again space get a space is printed, and then the last time, this, when we reach the end of the array, x represents 4, so 4 gets printed, and then the space is also printed. Okay, so this is how, this for loop prints the whole array. Okay, let's look at that. Okay, now let's look at the output. Okay, now let me execute the code. Yeah, so 1 2 3 4 5, because earlier the array was 1 2 3 4, but I pushed an element at the back of the array. Okay, now let's pop the element. Okay, so to pop the element, v dot pop underscore back. Okay, So let's see. Okay, before popping the element from the end of okay, the end of the array. Okay, and lastly, you know, here we have popped the element. Now again, if we try to print the element, okay, if we try to print all the elements, okay, okay, after popping the last element of the vector, okay, vector, this should be vector as well, okay, in case you are confused, this should be vector as well. Now let's see. Okay, so we haven't used end line here. Let's say we use end line here. Okay, see out. Either you can use new line character, okay, to put a line, to put the space in between, or to move the execution to the next line, or you can use simply end line. Okay, yeah, see out end line. Let's see. Yeah, so when we try to print after pushing the element 5 at the end, we got the array 1 2 3 4 5, but then we popped the element simply, so 5 gets eliminated from the vector, and now if we try to print we get 1 2 3 4. So yeah, this is how vectors work. Okay, now let's try to comment this. Okay, let's comment this out. Okay, let's comment this. Okay, let's comment this as well. Now let's see what are the other other functions that we can use with. So there is a function called capacity to know how much elements that a vector can hold. Okay, so let me go back. Okay, let me tell you what is capacity and what is size. Okay, what is the difference between these two. So in this case we had 5 elements, okay, in total, but the total elements that could be stored in the vector is 8. Okay, 8. So so if we try to print the size, it would be 5, but if we try to print the capacity, it would be 8. Okay, let's fill the 5 elements. Okay, and let's see what is the size and capacity. Let's go back. Okay, so now after pushing the element becomes 5, right? So now let's try to print the size and capacity. So size, okay, so this will be the size. Okay, v dot size, yeah, size. Okay, 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 so this is going to be the capacity, right? Yeah, capacity, and let's print the capacity. Okay, yeah, so we'll use capacity from. Now let's see the output. Okay, so the size is 5 but the capacity is 8. Yeah, so this was the whole difference between the size and the capacity function. Okay, so yeah, in the case of vector as well, you can use the empty function. Okay, how do we use empty function to check whether the vector is empty or not? V dot empty. Okay, yeah, simply now if we try to print this, it would give us 0. Why? Because the vector is not empty, right? It has 5 elements, so this is why we get empty here. Okay, now you can also access the elements using the index. Okay, see out, v of 4, the element at index 4 is 5, right, at the end. Okay, yeah, so we get 5 as the output. Okay, this is how we work with vectors. Okay, now the last thing that we'll talk about is deck. Okay, so let's go to the next page. Okay, let's add one more page here. So let's talk about deck now. Okay, deck stands for doubly ended queue. Okay, doubly ended queue, okay, it has okay, in this STL, or it is a kind of data structure, you can call it. Okay, because we are storing some form of data in these structures, right? Same in the case of vector is also a kind of data structure, and array is also a data structure. So now it is a data structure where we can write this as a note. Okay, note, we can perform insertion and deletion at both ends. Okay, at both ends. What it means is that in case of vector, we can only push the element at the back and pop the element from the back, right? We cannot do it from the front. Okay, if we try to, we'll get an error. Okay, but in the case of DAC, we can access the element at the front and from the back as well. Okay, you can read about all other functions in the documentation. I'll just tell you what is important. Okay, so yeah, so how do you push the element at the back? You can use simply push back function. Okay, so this is the syntax: push back and then element that you want to push at the end. Okay, how do we pop the element? How do we push the element at the front? Okay, so you can use push front. Okay, yeah, push front and then the element that you want to push at the front. Okay, similarly you can use pop back to pop the last element, and you can use pop front to remove the first element. Okay, now yeah, so this is how okay, you will write the name of the deck as well. D dot, let's say D is the deck, so D dot D dot D dot D dot. Okay, you will use dot operator to use these functions. And to work with deck, you will have to include the library. So has include, you'll have to write this at the top, dq. Okay, this is how you can work with deck. Okay, uh, you use other functions as well with deck. So the other functions that you can use with deck is at I. Okay, since we can use the index to access the particular element in the index. Okay, at the index, let's say we have 1 2 3 as the deck. Okay, now to get the element, okay, indexing will be like this, right? To get this element, we'll write d, let's say deck is d dot at 2. Okay, it will give us 3 as per this deck. Okay, now we can use empty function as well, same way as we used it in the case of a vector, right? D dot empty. So it will tell whether it will give us boolean 0 or 1, whether the deck is empty or not. Okay, if it is empty, it will give us 1, otherwise it will give us 0. Okay, now let me move to the next page. Okay, yeah, so we can also use erase function here. Okay, erase. So the syntax of erase function will be erase starting and end. Okay, from where we want to end. Okay, so let's suppose this is the deck 1 2 3. Okay, and we give it d dot erase. Okay, d dot begin. Okay, and d, okay, d dot begin plus 1. Okay, begin plus 1, not the end of the deck, but the end where till which we want to erase the element. Okay, so d dot begin comma d dot begin plus 1. Okay, plus 1. So it will erase just the first element. Okay, just the first element, the first element. Okay, so now the deck becomes something like this, 2 comma 3. Okay, let's see how it works. Okay, let's create another function, another you know okay, uh, yeah, so let's create another program, dq.cpp. So let's write the boilerplate code. Okay, 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 so to work with deck, I already told you that you have to include the library. Okay, dq. Okay, yeah, this is how you include it. Now we can work with deck. So let's create a deck of type int. Okay, you have to give the data type here. Okay, this is the syntax. So deck, then within these arrow brackets you'll give data type, and then the name of the deck. Let's say I name it de. Okay, or we can name it d only. Okay, let's say I give it elements 1 2 3. Okay, now let's say I want to work with push and pop operation. Let's say I want to push at the back. Okay, so d dot push underscore back. Okay, let's say I want to push 11 at the back. Okay, let's say I want to push at the front. Let's say I want to push minus 5. Okay, so d dot push underscore back minus 5. Okay, yeah, so let's see what is the output. Okay, for auto x belongs to d. Okay, similarly in the as we done in the case of vector, we can use auto keyword here to access the elements. Okay, cout x and then space. Okay, I already told you how this work. Okay, so let's try to execute the code. Before that, clear the terminal. Okay, let's run the code. Yeah, so we are getting 1 2 3 11 and minus 5. Okay, I again pushed it back. Okay, so let's push it front. Okay, push front. Yeah, so now what we are going to get, minus 5 1 2 3 and 11. Okay, let's see. Yeah, minus 5 1 2 3 and 11. Okay, you can you can move it up or down, doesn't matter. Okay, yeah, So even if you move it up, okay, the output would be the same. Okay, yeah. So now let's see how, you know, uh, now this is the deck. Okay, new deck. Okay, so let's say we want to erase the last element. Okay, what we'll do, we'll simply give it the command d dot pop underscore back. Let's say we want to erase the first front element first. Okay, so d dot pop front. Now let's try to, you know, okay, so yeah, let's try to print. Okay, yeah. So last element, first element has been removed. Okay, let's say we want to erase last element instead of, okay, let's not do that. Okay, let's erase this. So the vector, so the deck again becomes this. Okay, we have erased that particular statement. So let's say we want to, you know, because the execution is line wise, right? So now the, let's say we want to erase only the last element and not the first element. So pop underscore back. Okay, okay, let's see what is the output. So the output will be minus 5 1 2 3. Yeah, so minus 5 1 2 3 is the output. So this is how we work with deck. Okay, there are other functions as well, you know, empty, you already know, you know how to work with at. Okay, I already told you that in the vector itself, so we are not going to discuss that. Okay, now lastly, what we are going to talk about is a list. Okay, I okay, so list is the last. Okay, so what is a list? Okay, list uses doubly linked list. Okay, it uses doubly linked list data structure. So what is a doubly linked list structure, data structure? Okay, so a doubly linked list data structure has pointers for both the front element and the back element. So it stores element this way. Okay, there are multiple nodes. Okay, and there is a back pointer and there is a front pointer. There is a back pointer, there is a front pointer, there is a back pointer and there is a front pointer. Okay, so let's suppose there is an element 3 minus 5 to 11. Okay, so this is how the elements are stored. Okay, each element has a pointer to the back element and a pointer to the front element as well. Okay, so now what we can do with list? Okay, to work with list we have to include the library as include list. Okay, at the top. Now what are the functions? So you can do the same thing as you did in the uh, in the case of deck. Okay, so you can push front. Okay, you can push back. Okay, push front, here you'll have to pass the element. Okay, and here also you'll have to pass the element because you are pushing the element, right, and not popping the element. So you can either push back, push front and push back, and you can also perform deletion. So you can use pop back. Okay, pop back and pop front. Okay, let's see how it works. Okay, if you want to erase the element from the front, you can use pop front. If you want to erase element from the back, you can use pop back. Okay, now let's see how we work with list. Okay, so let's create another program, list.cpp. Okay, let's type the boilerplate code. Okay, yeah. So now let's say to work with list, I have already told you that we'll have to include this library. Yeah, so now we can work with list. Okay, so let's create the list. Okay, list of type, let's say int. Okay, to store the integer values, let's say I name it l. Okay, l is equals to 1 2 and 3. Okay, yeah. So now let's say I want to push element at the back, l dot push underscore back, let's say element minus 4. Okay, so now let's try to print it for auto x belongs to l. Let's print the element. Okay, x. Okay, now if we try to print, what we'll get, we'll get 1 2 3 and minus 4. Yeah, so we'll get 1 2 3 and minus 4. Now let's not okay, so this is the new list. Okay, remember this is the new list, not this now. Okay, now let's say we want to push the element at the front as well. So l dot push underscore front. Okay, front, and let's say the element that we want to push at front is 5. Okay, Now let's try to print the list again. Okay, let's try to print the list again. Before printing, let's use the end else statement. Okay, or you can use new line. Okay, it will do the same thing. Let's print. So earlier the list was 1, 2, 3 and minus 4. Now after pushing 5 at the front, we get the new list printed, which is 5, 1, 2, 3 and minus 4. Okay. Similarly, you can use pop operations also. Okay. So let me perform the pop operation. Let's erase the last element. Okay. To erase the last element, L dot pop front and okay, L dot pop front. Okay. Now let's also give the new line so that it prints on the next line. Okay. Now let's try to print again. Okay. Okay, let's try to print again. Let's see. So we are getting 1, 2, 3 and minus 4 because we are popping from the front. So 5 gets removed. Okay. Now let's try to pop from the back as well. Okay. Let's try to remove 4. L dot pop underscore back. Okay. Now let's try to, print this again. But before that, let's use end line. Okay. Or let's use new line character. Okay. So in the fourth case, we get minus 4 removed. Okay, so only 1, 2, 3 we get as the output. So yeah, this is how we work with sequence containers. Okay, so that was all about this video. Hope to see you in the next video.